this video, we're going to have a look at an example of computing both cross product and dot product. So this is a tougher example. At this point, you should have already viewed the video or be familiar with how to compute the dot product of two vectors. Also, you should be familiar with how to compute cross product. If you're not, there's example 1. That video is a bit simpler, so that'll give you the basics of computing cross product. So let's go ahead and work out this problem. Here specifically, you're asked to find the dot product of the vector u with the vector corresponding to the cross product of v and w. U here is 4, 1, 2, v is -3, -4, 1, and w is 5, 0, -2. So go ahead, try this out, and then we'll continue together. In terms of what you're going to be doing, first you're going to have to find the cross product of v and w. The formula for the cross product is shown here, but it's a general formula where the vectors are u and v. In this case, the vectors we want to find the cross product of are v and w. So you're going to have to be very careful in using the formula, which is in terms of u and v, to here compute the cross product of v and w. This very often happens in mathematics where the formula we're given has different names than the names that occur in the question, so it's good practice for you to be able to do this here. Again, u has a different meaning in the question, so you're going to be very careful that everywhere you see a u in the formula, it's really the first vector in the cross product, so it represents v, and everywhere you see a v in the cross product formula, it's really the second vector in our cross product, so in other words, w. So again, the key is what we really want is v crossed with w, and if we like, we can even just go ahead and rewrite the formula here. It's going to be v2 w3 minus v3 w2. Second component is v3 w1 minus v1 w3, and finally v1 w2 minus v2 w1. That's a good first step to do, to rewrite the formula in terms of the vectors we're going to be using. Otherwise, it might get a bit confusing as to which components and which vectors we're going to be dealing with. So this is always a good strategy. Make sure that the formula isn't confusing you. So again, now we're just going to have to find the cross product. And to do that, you just follow the formula. So select the appropriate components of the vectors v and w, multiply and subtract them as indicated, and you'll get a new vector, which is the cross product of v and w. Once you've done that, you can then find the dot product of u and this new vector you've just found. As a reminder, to find dot product, you simply multiply corresponding entries in the vectors and then add the results together. So again, go ahead, try this out, hit the pause button, and then hit play when you're ready to continue, and we'll take this up together. Okay, so hopefully you've had a chance to try this out. Let's go ahead and take this up. Again, you're finding the dot product of u with the new vector corresponding to the cross product of v and w. So let's go ahead and find that cross product. So first of all, let's just write out all our vectors. So u is the vector 4, 1, 2. And we're finding the dot product of that with the cross product of the vector -3, -4, 1, so v, and w, which is 5, 0, -2. So again, let's go ahead and find the cross product first. So we have 4, 1, 2 dotted with. So to find the cross product, we're doing second component of the first vector, so v2, so -4 times third component of w, minus third component of u times second component of w. That's the first component of our new vector. Next, v3 w1 minus v1 w3. So third component v, first component w, minus first component v, third component w. And lastly, we have v1 w2 minus v2 w1. So that means we have first component of v, second component w, minus second component of v, and first component of W. And let's just go ahead and put all of our brackets in just to be clear. This is a vector that we've got. So now let's go ahead and simplify a little bit, just doing the arithmetic so we can figure out what this cross product vector is. We've got -4 times -2, so 8 minus 0. So we've got 8 as our first component. 5 minus 6, so -1 as our second component, and 0 minus -20, so +20 as our third component. Finally, let's go ahead and compute the dot product. So now we're going to multiply the first component of the two vectors together. So we're going to get 4 times 8 plus, we're going to multiply the second components together, so 1 times -1, plus we're going to multiply the third components together, so 2 times 20. If we go ahead and clean this up, we're going to get 4 times 8, which is 32, minus 1 plus 40. So 32 minus 1, so 31 plus 40. So we're going to get an answer of 71. Again, just to recap what we did, we first found the cross product of the vectors v and w using our cross product formula. Remember that it helped to rewrite the cross product formula in terms of the names of the new vectors so we didn't get confused when we applied it. V cross W gave us a new vector, and then we were able to find the dot product of the vector u with this new vector, which was the cross product of v and w. To find the dot product, we simply found the sum of what we got when we multiplied entries in like components together. So in other words, we multiplied the first components together, added to that what we got when we multiplied the second components together, and added to that what we got when we multiplied the third components together. The final answer then is just a number, a scalar, as we would expect whenever we do dot product.